Well, Happy New Year, guys. Today is January 1st, 2023. My 1 year beard is coming right along. I haven't cut this since August when I retired from the Army. And we'll see if I can make 1 year. I'm gonna do my best to not cut it, to let it go through its phases until next year, and then we'll decide what to do. But anyway, I digress. I've got an interesting project that I thought I would bring you along with me in milling. I milled the first one yesterday, and I think I worked through the kinks. We're going to mill another one today, and I'm going to film it. What I like about this project, it has some interesting probing. It really demonstrates well how small a bore the Pioneer probe can go into and still get an accurate WCS. In this case, it's X and Y. There's interesting tapping. There's also, I'm going to attempt to do wear. So I've got Fusion 360 set up with wear for this bore here, okay? Let me bring you in closer and I'll show you what we've got here with this thingamajigger. So this is the part that I'm working on, okay? This is intended to be a vise stop where this slot here will screw into this 6mm hole on my vise. Okay. Now I've got two movable jaws and a fixed jaw, but they all roughly look the same as this movable jaw. So using this 6mm thread, I plan to be able to adjust it, okay, in and out and up, right where I need to. And then this hole here will accept a 6.35 or 250 thou, or sorry, 1/4 inch precision rod. Okay. Just a little project I thought I'd do. And what I like about it is, well, it's a small part. As I said before, for OP2, I need to probe this hole here. Okay. OP1 is straightforward, except after OP1, I want to be able to measure this bore and this slot and make sure that, you know, go, no go, will this fit through here? And will this is a 1/4 inch pin or rod, precision ground rod, and I've mic'd it at perfectly 250 thou. So to make this hole, I'm using an 1/8 inch end mill. Unfortunately, and I'll try again, but I am unable to get my diameter or radius for the 1/8 inch end mill. And it's a little troublesome without the right equipment to measure the diameter of an end mill. I mean, I could try with a caliper, but I don't want to scratch the anvil or whatnot. So what I'm going to do is, after OP1, I've programmed in an inspection, or after this bore, I programmed an inspection, and then I'll go in and do a go, no go, okay? And then I have a separate operation that I can adjust the wear in the Siemens controller. Hey guys, before we get too deep into this video and I bore the living hell out of you, just know I've got chapters below. You can skip around if you don't want to hear something and want to skip to the end. Do the chapters. Also, I'm on Instagram. I don't film every day, but on occasion I do post to Instagram. If you're interested in seeing what I'm up to, go there. Also of note is when I flip this part, two things. I don't want to put in this serrated edge into this stock, okay? Also, it is sitting proud of this by about 1 millimeter. And when I go in through my chamfer it, I don't want to risk of rubbing once again on my fixed jaw. I've rubbed that thing a few times and milled into it. But I want to save that. So yesterday, if you check my Instagram, you'll have seen this. I have created additional steel jaws to bolt into the face of my fixed jaw and my movable jaw, and then I've machined in there a 3mm step, 3 down, 3 over. So on my OP2, I can add those soft jaws. Imagine this is my soft jaw. Place it in and then do my OP2. Here's a quick look at what I got programmed in Fusion 360. OP1, which is the top profile. We've got a standard probe. We're going to face it, do the outside, and then work my way inside. I'm going to do this bore again with an 1/8 inch end mill. This bore will go all the way through the stock, so I have something to probe on the OP2. Then comes the contour. This is my critical dimension. Right now I've got this, a sliding fit is at 6.477 millimeter. So it can be -0 or plus, you know, whatever, so that I just need that, that pin to be able to go through there. Right after that, I have a manual inspection, and then you can see that 6.477 on that manual inspection. I've never attempted to use manual inspection in Fusion before, so this is cool. So if all goes well and the Fusion works well with my post-processor, the machine will stop, and I will be able to do a go, no-go with my pin. Then I have the adaptive, the same tool to mill this slot, okay, and contour, and then chamfer. What I've gone ahead and done ahead of time is I have created an operation called wear operation, okay? And only in this toolpath do I have it set up as wear. Normally I just run in computer and that's fine, but with wear it's going to, if I hover over this, it'll actually do a pop-up. But with wear it'll do the G41, G42 codes to use the in control values, and in this case it says enter the difference as a negative number. So that's what I'm going to do. Again, I know it's a 1/8 inch end mill. I haven't been able to measure small end mills on my tool setter before, and I don't know where it cuts off. Maybe it cuts off smaller than that, but I think it might start cutting off at 1/8. That's a drawback with my tool setter, because I do like to do, I mean, I kind of enter into micro machining just a little bit, but I do use small end mills. Okay. So with this wear operation, I'll be able to redo the, oh, you know what? Let's fix this. Stock from preceding setup, continue rest machining. Okay. So with this wear operation, I'll be able to adjust and run, adjust and run, adjust and run until I have my go. Once I have my go here, then I'll know I'll have met my go here. And then I can sort of use that negative value that I end up with in control to guesstimate what my end mill is actually running. Okay, so that is my wear operation. My bottom profile will require me to flip this, okay? My Z is, whoa, I can't drive. My Z is at the bottom of the part, so I can get an appropriate top height, okay? And then my X and Y are in this bore. Excuse me. So on OP2, I'll be adding the soft jaws. I'll take off the hat, which is a little interesting because if this feature here is already milled off, there's a good chance that, a 50-50 chance that a big chunk of this will shift and won't mill away because there's no floor underneath it. So that'll be interesting. If you guys have a better strategy of doing something like that, I'd like to hear it, but I'm not going to use a face mill. I'm going to use a 3/8 inch end mill to take off the top, leaving 0.25 millimeters on the floor to clean up with the face in one pass. And I'll get a uniform finish like I do with the other side. Now this part will be exposed. I'm going to probe it again in X and Y just to make sure that I'm right where I want to be so that my chamfer is in line. I don't want it to be offset even by a little bit, my chamfer. And then for the last operation is the tapping operation. So I'm going to flip this up on edge, get my WCS above this bore, okay? And then I'm going to spot drill it out. I believe it's a number 39 drill, and then tap it with an M305 drill. A little prolonged tapping with chip brake. It's kind of a fun tap. I love that tapping operation. As always, I'm going to give you guys a little bit of machining. Get this thing chucked up, get some chips going, and we'll see how this works out. Okay, guys, two things happened. One, when I posted the G code, my post processor does not allow me to use where or inverse where or in control. It only allows me to do computer. And then I've had an inspection set up, so prior to the chamfer, this should have stopped and let me test this, and it did not do that. So I do have wear on my control, and I'm going to measure this, and then if it's too small, I'm going to adjust my absolute wear on the Siemens controller, run my wear compensating program again like that, and see if it does anything. Oof. Oh man, that's tight. This, okay, that fits perfectly. This is 0.650. This is 0.6447, just slightly smaller. This almost goes in, and that goes in. Okay, I'm going to run the wear compensation program actually, and just do a spring pass on these two, and then we'll test it again. Maybe that'll do it, and I won't have to worry about wear. But I would like to figure out wear. That's important to do. Granted, I only do projects for myself, but if I do something for someone else, I'm going to need to sneak up on that measurement. So let's run this again. Okay, you see what I see. Nothing fancy here. I'm going to go in and do my wear op. It's the same G54. Just in case I screw up, though, I've got my finger over the stop button. I never screw up, except always. Let's try this. I've got the scars on my vise to prove it. Whoops. Let's test this again. Oh. Well, shit. All right, I've updated my wear by 0.01 millimeters. And I'm gonna run this again and see if it takes off a little bit more. I couldn't get this all the way through, and now I can get it all the way through after running that second operation. I updated the wear table in the absolute value. I didn't change it to incremental. I ran absolute, and I put in 0.01 and ran it again, and now it fits. So I have a little bit of wear on the 1/8 inch end mill, and no doubt some deflection in the tool as well. Okay, here is part number 2, and what I'm left with, you'll notice in here, I've got a little burr from the tap and the drill, actually from the drill. But if I just take a round file and a half round file, you know, I can work that out. There it is. And then in here, I need a little grub screw. A little 3 millimeter by 4 millimeter grub screw is what I'm going to use. They're really small. Stay there, screw. Which requires a 1.5 millimeter Allen to drive it. Okay, so I can adjust this back and forth to get to the stock that I'm measuring in the vise, and then again use this with a 6 millimeter machine screw to fix this to the vise itself. Let's go see it on the vise. Right here on the vise, on each side of each jaw, there's a 6 millimeter threaded hole, compliments of the manufacturer, that I can make some accessories like this. So again, there's a little bit of play. This is for limited cases that this would work, not for everything. But you get the general idea. Put it where you want it and tighten it up. Well, all in all, I think that was a fun project. Really low tolerance on the vise. It's nice to know I can make something this small. Great test of the probe. It actually, let me flash some pictures up there. When I did another probe here and then stopped the program so I could see the dimensions, and it measured 6.4 and change. Obviously this fits. I think the hole is 6.447, and you'll see with the probe here 6.4 and change. And then the discrepancy, the deviation, was about 1 micron, 0.001 microns in each of the 4 coordinates, and that's pretty darn good. So I'm very happy with that. The jury's still out on where. If anyone knows how it really works with this Siemens 808D Advanced Controller, please let me know. I ended up running it in computer. My post processor does not support in control, wear, or inverse. Yeah, I think those are the 3, and then there's off. But I have absolute and incremental settings in the control that I can plug in manually. I'll do some more testing, more significant testing than fractions here or there, to see what's going on and try to understand it. But again, if anyone has some experience with that, please edify us all and leave a comment. Once again, Happy New Year. I hope this year is as fantastic as they all are, as last year is. And yeah, take care. Catch you on the next one.